Hey everybody. So I've already gotten some of your homework. I appreciate that you guys are attempting the homework and really making that push for the AP test. One topic that I wanted to make sure I hit home because it's a very fine detail is the idea of partial sums. So it kind of goes back to what it means for a infinite series to be convergent or divergent. So well, first, this is a screenshot from the Paul's online notes. It's the link in red on the Google Doc. These are really, really great notes to help you understand the topic better, so I really recommend looking at them. In particular, it makes this claim, and that's the thing that I'm going to talk about today. But essentially it's saying, right, so let's look at this infinite sum, right? So the sum of the series from starting from I is equal to 1 to infinity of a sub I is equal to the limit as n approaches infinity of s sub n. Well, first, that's a lot, but what is s of n? And s of n is partial sum. So let's start with an example first. Let's look at this example right down here. Let me scroll down a little bit. So we're looking at the series, the sum of n starting at 1 to infinity. Let's write out all of the terms. So it's 1 plus 2 plus 3 plus 4 plus 5, on and on, infinitely many times. What are the partial sums? Okay, so the partial sums represent the sum up to a point. So let me be a color coding kind of guy. So the first partial sum is 1, because that's the sum starting from the first, well, until the first term. Okay, so the second partial sum is the sum of the first two terms. Okay, 1 plus 2 is 3. So the third partial sum is 1 plus 2 plus 3, the first three terms. And you can kind of see below, the fourth partial sum is the sum of the first four terms in this infinite series. So you can think of an infinite series, right? It's a little bit confusing because like we're just adding a ton of things. And it's kind of hard to wrap your head around what exactly is going on. So a convenient way to think about how a series behaves is by looking at the sequence of the partial sums. So by looking at these numbers, I'll be color coding. Okay, so this number, this number, this number, and this number. This is a sequence, okay? What's happening to our sequence as n approaches infinity, as we keep looking at all of the partial sums? Well, for this example, it looks like the numbers are getting bigger. And you can kind of make that guess that this sum is going to diverge, right? We're just going to keep adding a ton of numbers, one bigger than the next, right? So if you were to talk about the limit as n approaches infinity of this string of numbers, and it's getting bigger and bigger every single time, you'd say it would diverge, right? But if we wanted to be a bit more concrete, a bit more discrete, an equation would be lovely. And it turns out this type of sum can be written out in explicit formula. And the explicit formula is down here. Okay, I'll bring it up here first. Okay, so S of n, the nth partial sum, would be equal to n times n plus 1, right here. So for example, if I wanted to know the 100th partial sum, it would be 100 times 101 all over 2, right? Conveniently, we know how, like, the value of the sum up to the 100th term. And by looking at this enormous number, you're really starting to think, okay, this series is going to diverge. So we can talk about, okay, what's the limit? What's the limit as n approaches infinity of this discrete equation, this partial sum? Well, if you kind of like plug in infinity, or however you like to think about this sum is going to approach infinity. well, this equation is going to approach infinity, so therefore this sum is going to approach infinity, so that means our series diverges. The important point that I wanted to make, and the mistake that I kind of saw in the homework, was you have to recognize that these are not the same thing, okay? The series, the sum of n from n starting to 1 to infinity is not equal to n times n plus 1 over 2. They don't represent the exact same thing, okay? They're not the same thing. The right-hand side of this equation tells you how much the sum, tells you how much, like what value the sum on the left-hand side is for some value of n, okay? But the equation on the left-hand side is the sum from n all the way up to infinity. So a better way of thinking about it is that these two represent the same thing. There's some finer details of like the variables, but essentially the sum of n from n starting to 1 to infinity is equal to the limit as n approaches infinity of n times n plus 1 over 2. But the thing is, it's not always easy to get an equation like this, right? It's not obvious from looking at an equation to just get this looking at a series to just get this equation. So in the homework, I asked you guys to determine whether or not a series was convergent or divergent based on the equation of the partial sums. And I saw somebody use the divergence test to determine it, and that's not the case. We can't just use this test because you have to remember that the divergence says that the divergence test says if the limit as a sub n, let me highlight it, of a sub n as n approaches infinity does not equal 0, then the sum from n starting to 1 to infinity of a sub n diverges, right? So a sub n is, if you want this in like very simple terms, is the thing next to the sigma. So technically, for our example, the thing next to the sigma is n. It is not n times n plus 1 over 2. So if we wanted to use divergence test, we would use this limit, not the second limit. Well, if you looked at the limit as n approaches infinity for both of these examples, well, both of them approach infinity. But that's not always the case. For example, let me write one up. Let's say we wanted to know the sum as n from n starting 1 to infinity of 1 over 3 to the n minus 1. It turns out, and this is directly from the notes, so you guys will see this. So the sum of 1 over 3 to the n minus 1 from n is equal to 1 to infinity is equal to this. 3 halves times 1 minus 3 to the n. So 3 halves, its partial sum is equal to 3 halves times 1 minus 1 over 3 to the n. Okay, so let's take the limit. Let's take the limit as n approaches infinity of 3 halves 1 minus 1 over 3 to the n. Well, as n approaches infinity, this term approaches 0, so that means this will just be equal to 3 halves. Oh, does that mean our series converges? It does, right? The limit as the partial sums approach infinity, the limit as the nth partial sum approaches infinity is equal to a finite number. That means our series converges. But if you tried using the divergence test for this series, right? So the limit as n approaches infinity of 1 over 3 to the n minus 1, this approaches 0, right? The denominator is getting really big, so 1 divided by a really big number is 0. Well, if the limit as n approaches infinity is equal to 0, we can't use the divergence test. So the divergence test actually doesn't help us in this example. Okay, so this was just a finer detail I wanted to make sure that you guys notice. You can only use the divergence test for a sub n, the thing next to the sigma. I hope this helps.